In question 70 we're given this genetic table which gives the genetic codes for amino acids. As you can notice, they're all in groups of 3 turned triplets or codons in the DNA sequence, and then we're given a base sequence showing the middle part of a gene encoding a protein, which is written here, and we're told that mutations took place in the 4th and 20th, seen here, bases in the sequence. Okay, we're then told, using only the information provided and reading the sequence from left to right, we should then assess the following 3 statements to see whether they are true or false. Okay, so the first statement, the sequence could only be 6 amino acids long. Well, under normal circumstances we have more than 6 sets of triplets, so we wouldn't think, or codons rather, we wouldn't think that this would only be 6 long, but we have this mutation to reckon with in the 7th amino acid, which you can see here is trip under normal circumstances, but could mutate. The guanine can mutate into an adenine, producing a stop, producing a 6 long amino acid. So that's absolutely right. Moving on to 2, the 2nd amino acid could be unaffected by mutation. Well, when we know that the mutation has taken place, but given the genetic table we can see that CGA encodes ARG, but the same can be said for AGA, which also encodes ARG, so if the C were to mutate into an A, which it may well do, then there would be no change to the overall protein sequence, amino acid sequence, or the protein as a whole. So we can say that's also potentially true, and we can say for 3, the sequence could obtain 7 different amino acids. Well, that will involve counting up the number of amino acids we have under a normal circumstance, which we can do. So ATG, that's MET, so we can remember that. CGA is ARG, so that's a different one. GAC is ASP. ATG is MET again, so we can ignore that. TTA is LU. AGG is ARG, which we've already had. TGG is TRIP, which we haven't had before, so we can note that. GAC is ASP, which is new again. CCC is PRO, we can note that down. CGA we've already had, and GTC encodes VAL. Okay, so we can make a quick note of all of that and tally it all up, and we can see that under normal circumstances, even precluding the mutations, we have 7 different amino acids, so this is potentially true, of course, because it is under the normal circumstance. So we have our answer, which is H. All 3 of them are true.